This is Callie White, and the theorem I decided to prove is that the diagonals of a parallelogram bisect each other. So you start off with a parallelogram, and you draw the diagonals. And then you give them some names. And then to make it a parallelogram, you draw the arrows. Alright, and then the definition of a parallelogram, which is a quadrilateral that the opposite sides are parallel, and that means that line segment AB is parallel to line segment, wait a minute, this is, okay, is AB is parallel to DC, and since the opposite sides of a parallelogram are congruent, line segment AB is congruent to DC. And the alternate interior angles are also congruent, which means that angle BAM, this, is congruent to angle DCM, which is this. So these are congruent. And that also says that angle MBA is congruent to MDC. So these two are also congruent. And that gives us side angle, side angle. And that being said, means that triangle AMB is congruent to triangle CMD. And since corresponding parts of congruent triangles are congruent, that means that line segment DM is congruent to MB, and that line segment AM is congruent to MC. And the definition of a segment bisector, which is a line or a segment that cuts another segment in half, says that M bisects line segment AC, and it also says that M bisects DB, which is proving the theorem that diagonals of a parallelogram bisects each other. Thanks.